the height approach to L, right? So you write the height approach to L there. Similarly, go to A from the right side. Look at the height from the right side of A, but very close to A. You see that? As soon as you get close to A, the height of the function is close to L. So from the right side it is L, from the left side it is L. What is the notation? If you want to write the height of the function, when you go to A from the left, you write A minus. For the right side, A plus. Okay? Since both are equal, then you write it is the limit exists and it is equals to L. Sometimes you get the different height from the left and different height from the right. In that case, we say the limit does not exist, D and E. Okay, in that case. But in this example, the height of the function close to A from the left and close to A towards the right are equal. That's why the limit is L. Limit equals to L and the limit exists here. Okay, so next thing we do is I will give you the epsilon delta definition of the limit. Okay, so before I give you the definition epsilon delta, again epsilon is a very small number, delta is a very small number. Before I give you this definition of limit, let me review how did we find out the limit of a function at a point by using table or chart. Okay, so you see that what I want to do to find out the limit by using the table or the chart is what I do is I make a table x and then I do write down y, right? So I take different values of x around 1, okay, and then find out the values of y or fx. That is basically y, right? The fx is basically y. And then I will see where the values of the y approach when you approach to 1 from left side and the right side. Okay, so what I want to do, I want to find the values at 0.9, okay, 0.95, and then I want to find 0.99, and I want to find out the value of y at 0.999. I'm going to 1 from the left. Okay, so at 1 we don't know, I mean at 1 the value, functional value is 4 times 1, 4 minus 2 will be 2, right? But we don't worry at 1, but we look at the value left of 1 and right of 1, but very close to 1. So 1.001, 1.01, 1.05, and then 1.1. Okay, so I am basically getting close to 1 from the left and the right side, and I want to find out the height. So this will look like 1.6. The height is 1.6 at 0.9. What do? You can put this in calculator and then see. Okay, at 0.95 you will get 1.8. At 1.99 you will get 1.96. At 0.999 you will get 1.996. You see that? When you get to 1 from the left side, your y value or the height of the function is getting close to 2, right? Because it is 1.6, 1.8, 1.96, 1.996, and so on. Similarly, if you come from the right side, you will get at 1.1 you will get 2.4, and 1.05 will get 2.2, and this will be 2.04, 2.04, and this will be 2.004. You see that? If you go from the to 1 from the right side, the height of the function are getting close to 2. So what you can see is from there you can say that limit x tends to 1, fx is equals to 2, right? It happened to be the functional value of this function is 2 here, okay, but it happened to that way. But even if this function was not given at 1, we don't know, sometimes we don't know what is the functional value, but in that case too, the limit is 2 in this case, okay, for this function. All right, now the thing that we are interested here is basically we are interested to find how close should you take values of x near 1 in such a way that for example the height of the function or the value of the function, right, fx is within 0.5 units close to 2. See, we see that the limit is 2, right? Now I want to find out how close should you go to 1 in such a way that the height of the function is within 0.5 units close to 2. Look at this one. So you see that you are 0.001 close. This value means, you see that this value means you are 0.001 unit close from 1, right? If your x value is 0.001 unit close to 1, then your y value is how much close this value from 2? It is 0.00, is that 0.004, right? If you get 0.001 unit close, both of these x values are 0.001 unit close to 1. In that case, your y values will be 0.004 unit close to 2. You see that? Similarly, if you get 0.01 unit close, this is 0.01 unit close. You see that? This value and this value are 0.01 unit close to 1. So if you get 0.01 unit close to 1, then your y value will be 0.04 unit close to 2. You see that? Similarly, this one is, if you get 0.05 unit close, 0.05 unit close, this value and that value are 0.05 unit close to 1. And in that case, the y value are 0.2 unit close. You see that? This y value and that y value are 0.2 unit close from 2. And so on. Okay? So here the idea is, let us draw the graph. The graph of this function look like this. The graph of y equals to 4x minus 2 will look like this. 1 is here. So let's say this is negative 2, negative 1, negative 2, and then it goes through here. This is 1. Okay? So what it says is, basically, so you are getting close to 1, right? Because you are trying to find out limit. You already found that limit x tends to 1, fx equals to 2. At 1, close to 1, the height is basically 2, right? If you get close to 1 from the left, basically height is very close to 2. And if you are getting close to 1 from the right, the height is also close to 2. Now the idea is, if you want to be the height within certain distance, 0.5 units. So if you want the value of fx or the value of y within 0.5 units from 2, that means 1.5 through 2.5. Okay? Then how close you should take the values here for x? That's what you are trying to find out. Okay? Again, if you want to be within 0.5 unit close from fx or from y, from fx here, how close should you be for x? How close should you go to 1? How close to 1 should you go? So in other words, if you use the absolute value notation, what it is saying is, it is saying that if you want to be f of x minus 2 is less than 0.5, how close should you go? X minus 1 is less than what? What is that? That's what it is asking, right? In other words, if you want to be 0.5 unit close from 2 for fx, how close of 1 should you go in x-axis so that the height of the function will be 0.5 unit close from 2? Okay, that's what it is asking. So how do I answer this question? It is easy. So what you do is you just basically you start from that. So f of x minus 2 is less than 0.5. Okay, so what is the value of f of x? F of x is 4x minus 2. That is fx, and then there is minus 2, that is another negative 2 there, right? Is less than 0.5. 5. How much is that? It is 4x minus 4 is less than 0.5. You see that? Now, how do I get rid of the absolute value? You write that on the left side, negative 0.5 is less than 4x minus 4 is less than 0.5. Now you try to solve for x minus 1. You see that? You try to solve for x minus 1. Okay, so our goal is to find out the absolute value of x minus 1 less than what? Okay, that's what our goal is. So what I want to do is I want to divide by 4. Okay, if I divide by 4, divide this by 4, divide that by 4, what do I get? So what is 0.5? What is 0.5 divide 4? That is 125, 0.125. So 0.5 divide by 4 is 0.125. So that will look like negative 0.125 is less than, so 4x divided by 4 is x, and then minus 4 divided by 4 is 1. Okay, that is 0.125. You see that? Now how can you write this using the absolute value? So this absolute value of this is basically absolute value of x minus 1 is less than 0.125, right? Because if there is a negative number on the left, the same negative number on the left and the right, on the positive number on the right, but the value are the same, and there is something on the middle, then you can write the absolute value of the middle is less than that value. That's the definition of the absolute value. Okay, so x minus 1 is less than 0.125. So we answer, right? This value is basically 0.125. What does that mean? That means if you pick x value that is within 0.125 units away from 1, or within that distance from 1, then the height of the function will be 0.5 units, within 0.5 units from 2. Okay, that's what it is saying. So if you take this as 1.025 and 1.125, and then that will be 1 minus 0.125 will be how much? That will be 0.875. Okay, so if you take the x value between 0.875 and 1.125, then your y values will be 0.5 units, within 0.5 units from 2. That is 1.5 through 2.5. Okay, so basically if you want to get the height of the function within certain units from the limit, then you can find out those values there. How close should you go to that number? Okay, so that you will get the height of the function within the desired value, within the certain value that you want to have. Let fx equals to 2x plus 3. And the question is, how close should you take values of x? There is 1, 2, right? How close should you take values of x from 2? How close should you go to 2 from the left and right, so that the values of fx are within 0.1 units from 7? Suppose 7 is certain here. Suppose that is 7. Okay, so how close should you go to 2, so that the height of the function will be within 0.1 units from 7? That is 6.9 through 7.1. That's what it is asking. Okay, so how close should you go to 2? That means x minus 2 is less than how close? What? This is the question mark. How close should you go to 2? So that you want the values of fx within what unit? 0.1 unit from 7, right? Fx minus 7 is less than 0.1. That's what it is saying. How close should you go to 2, so that the values of fx are within 0.1 units from the 7. So what do? You start from this one. Okay, so let us start. What is the value of fx? Fx is 2x plus 3. So let's do 2x plus 3 minus 7 is less than 0.1. Okay, so now simplify that. So you'll get 2x minus 4. See that? Less than 0.1. So what you do, I want to get rid of the absolute value. So, and then we will plug in later to get x minus 2 in the middle. So one way of doing that is you can divide by 2, directly divide by 2 here. If you divide by 2, what do you get? It will be x minus 2 is less than 0.1 divided by 2, right? You can do that too. That is perfectly fine. Or you can get rid of this absolute value and then get absolute value again, get back the absolute value again, okay? So let us do that. Negative 0.1 is less than 2x minus 4 is less than 0.1. I'm trying to do a little longer way, okay? So you will see how to do that, but you will get the same answer if you divide here or do that longer way. So let's add 4 on both sides, plus 4 plus 4. That will be 3.9 is less than 2x is less than 4.1, right? Now divide by 2. Divide by 2, divide by 2, divide by 2. So what do you get? You get 3.9 divided by 2 will be 1.95 is less than x is less than 2.05. You see that? Now you want to get x minus 2, right? So what does that mean? That means if there is certain number, then you will need that negative of that number less than x minus 2 less than the positive of that number, right? So you need the same number here and here. So let me subtract 2 from all sides. Subtract 2, subtract 2, subtract 2. What do you get? You will get negative 0.05 is less than x minus 2 is less than 0.05. See that? And then how can you write this using the absolute value? See, there is the same number on the left and right except the sign, right? And this can be written as x minus 2 is less than 0.05. So that is the number, that is the distance you need to go close to within 0.05 units. So if you go close to 2 within the 0.05 distance from 2, then your height of the function will be within 0.1 distance from 7. That's what the answer for this question, right? So this can be obtained directly dividing by 2 from here. If you divide this by 2, that by 2 and that by 2, you will get x minus 2 is less than 0.05. But sometimes you cannot get that directly, okay? If there is, especially if there is x squared or 1 over x for f of x, then you will have to do this way. This way will be more helpful, okay? But for the linear function, you can directly divide or you can do this long method, okay? This is how we do this example. Now let me give you the definition of the limit, another definition, or the mathematical definition. Epsilon delta definition is also called mathematical definition. Mathematical definition of limit, okay? What we say is, this is the mathematical definition. We say limit x tends to a f of x equals to L, or L is the limit of f of x if for any epsilon greater than 0, meaning if you pick any epsilon distance within 7, that's what it is saying, right? If you want to get the values of the height or the values of fx within epsilon can be 0.1, 0.5, 0.01, anything. For any epsilon greater than 0, there exists delta greater than 0 such that f of x minus L is less than epsilon whenever x minus a is less than delta. So it is saying exactly the same thing, right? So L is the limit of the function fx at x equals to a if you pick any epsilon distance around the L. That's what it's saying, right? If you pick any epsilon distance around L, suppose this is a function, right? There is a and there is L. So if you pick any epsilon distance within L, this is epsilon distance up, epsilon distance down, right? And if you want to know how close should you go, so for this value you will be able to find out the delta distance within A, so that you must get within the delta distance to obtain the height within the epsilon distance. That's what it is basically saying. Okay, this is delta distance. So for any small or big epsilon value, you will be able to find out the delta distance or the delta value around A, so that if you pick the value of the x within that delta distance, then your height of the function will be around the epsilon distance. You see that? If you pick here, then the height will be inside that, still inside that. Okay, any height taken within the delta distance from A will fall within the epsilon distance from L. That's what the epsilon delta definition of the limit. Okay guys, so the last example that I want to give on section 1.2, we are still on section 1.2, right, is this example. Find the limit x tends to -4 1/2 x minus 6. What does that mean? Meaning when the value of x is close to -4, where does the height of this function goes? How much would be the height of the function, right? So the basic idea is, we will see that in the 1.3 in details. Okay, what we do, you basically plug in that value there. Okay, to find out the limit, the one way is the graph, right? You draw the graph and then you check where is the height, what is the height of the function close to -4, left to -4 and right to -4. And that's one way. Another way is make a chart, plug in take different values of x close to -4 and then see what you get for the y, that is the fx or y. So another way is you just plug in that directly here. Okay, most of the time if the function is continuous, okay, so the limit always exists, meaning the limit is equals to the functional value there. Okay, so how do you find the functional value? So just plug in that limit there. Okay, and then whatever value you get, you will get the same value. So here in this case the solution is you just plug in that, it is 1/2 and then -4 minus 6, right? How much is that? -4/2 is -2 minus 6 is -8. So the limit of this function is -8. So the answer is -8. Okay, so this is how we find out the limit of a function directly. But we will see the detailed method to find out the limit of the function in the next section, that is section 1.3. Thank you guys.